Ladies and gentlemen, welcome to the second part here at Czechoslovakia Innovation and Technology stage. Happy that you are here with us. Just before we start, of course, I want to remind you that we have our Tilde live AI translation this year. That's a new thing. You can scan it right here. I checked it out in the first session. I think it was mostly right, but then we had those very sexy, rich accents here, and then some jokes started to pop in. So be cautious, it's AI, but it's working quite well, and it will serve us well in this next talk titled Using the Sky, Spectrum, Sovereignty and Satellite Integration in Europe, which I think is a logical continuation of the talks that we had in previous Czechoslovakia events here. And 1 year actually for tech is a long time to develop, and there are new things to talk about like direct-to-device satellite technology, European sovereignty, and other important topics that our dear moderator will tackle in the next 45 minutes. So with your applause, let's welcome our moderator, the Senior Policy Manager at Access Partnership, the leading experts in innovation, Mr. Gökhan Tok. Welcome, Gökhan. Take it away.
Thank you very much, Artis. So we have a very good lineup of speakers from different parts of the connectivity value chain. I'm going to start by introducing them, but before that, we have two big innovations in the satellite communications recently. One of them is direct-to-device. I think it's like one of the most popular topics in connectivity landscape right now. And the second is the satellite broadband. And we have the right people to speak about both of these. We are going to touch on the resilience angle, the integration with the terrestrial networks angle, and the European sovereignty angle as well. To start with, we have Uwe Bauder from Rohde & Schwarz. He's the Director of Public Affairs. Welcome, Uwe. We have Clemens Jones from Amazon Project Kuiper, Public Policy Manager. Welcome, Clemens. We have Juan Ramon Lopez Caravantes. He's the Head of Secure Communications Program Management in EU Agency for the Space Program. We have Richard Moore, Principal of Spectrum Policy from Ofcom. And finally, we have Jaume Sampera, CEO of Sateliot. So the way that I would like to move this forward is having a 5-minute introductory remarks from all our speakers. And in the meantime, I will ask you to think of the most difficult questions that you can ask them. Then I have my questions already. I'm going to start a conversation by asking my questions, but if there are any questions from the audience, I would like to prioritize them as well. So having said this, I'd like to give the floor first to Uwe, and I'd like to get his insights about direct-to-device and the rest of the integration between the satellite communications or non-terrestrial communications, let's say, with the terrestrial communications. Uwe.
Yeah, thank you very much, and thank you for the introduction. Maybe let me simply start a little bit to put Rohde & Schwarz, the company I'm from, a little bit into the light. So we are not a satellite operator, we are not an operator of terrestrial networks, but so to say, everything that works with radio waves is our DNA. So from that, we believe we can, let's say, have a more or less neutral view on many of the things that are being discussed. When it comes to satellite connectivity and specifically to direct-to-device, we have to see it in a blend of connectivity. And I would put my statement into this direction. I would not say it's per se something good, something bad, but we need to get redundancy in connectivity, and satellite connectivity, either broadband or direct-to-device, is one of the ways to enhance connectivity. And there are a couple of applications which can only be fulfilled by this type of connectivity. So many from us coming to Latvia may have enjoyed that the local air carrier is the first airline that has integrated a certain satellite connectivity. And the experience, I don't try to connect to airline networks in the plane, because this is the only time you can rest a little bit. But I was trying it out, and the user experience, I really have to say, it was fantastic. So all the applications that you have on the smartphone, which sometimes hardly work if you are in these plane connections, were working without any problem. So I think we are coming into a next step of connectivity, good or bad, because you're losing your quality time on the plane. But at this point of time, I think it's putting us to a next level on the one hand, but in general, I would say satellite connectivity adds another way in the overall mix for connectivity.
Thank you very much, Uwe. So we are mentioning direct-to-device and satellite broadband as two different technologies. Before going to Clemens and get his introductory remarks, I just want to mention that when we speak about direct-to-device, it is your smartphones connecting directly to the satellite, which is a very impressive technology. But in terms of the quality of service, in terms of the downlink, uplink capacity and speed, there are some limitations, mostly from the spectrum management perspective. But when we go to the satellite broadband, with the LEO constellations, there is a tremendous amount of change there. And having said this, I'm going to give the floor to Clemens, please.
Yeah, thank you, Gökhan. And as is introduced already, I mean, I would set the scene actually by underscoring that this is now a critical moment in the revolution of connectivity, I would say, because it's just enlarging, and we are witnessing a massive transformation with global communication systems, including satellite systems, coming into the broader mix of connectivity. And it's not longer optional, it's already a reality, as you mentioned on your flight here. And this transformation brings both opportunities and also responsibilities. Opportunities, we can finally bridge the digital divide, hopefully. Responsibilities, we have to make sure that our space operations will remain sustainable and secure. And but overall, I would say we now have multiple operators in multiple orbits. This extends our possibilities regarding resilient communication infrastructures. And in order to achieve that, I think we have to make sure that we balance crucial objectives, one being a regulatory framework that promotes innovation, and second, ensuring an efficient use of these orbital resources. Now, maybe a quick intro into what Amazon Kuiper is planning to do. So we are a low Earth orbit satellite constellation consisting of approximately 3,200 in the first phase satellites providing broadband access. So the second package that you just mentioned. And non-geostationary satellite systems actually represent a revolutionary approach to connectivity. Basically, 3 points to mention: increased performance with low latency, true global coverage, and in addition, improved affordability compared to traditional satellite systems. And this is true for Kuiper. This is a new generation and consists of basically 3 parts, one being the satellites, 2 being the ground stations. We will have globally spread out several hundreds of those, and the customer terminals that then will be used to connect to the satellites. And combining those things will allow us to provide a communication service for all sides of different customers, and actually providing speeds that can be compared to traditional terrestrial infrastructures. So just this September, we had a live demo of our enterprise-enabled device, and that actually delivered more than a gigabit per second, which is unprecedented. So at least to our knowledge, no phased array antenna has ever delivered that speed from low Earth orbit. So with that comes a lot of new opportunities and use cases for different scenarios. And we are right now in the process of launching. We are just finished our 5th commercial launch last week, which brings us to 153 satellites in orbit at the moment. But in total, we have secured 80 launches. And as a European citizen, I'm very happy that we also secured 18 launches with the European rocket Ariane 6. And I'm very much looking forward to the first one on the Ariane 6. With that, maybe I'll leave it with that. I'm happy for the ongoing discussion. And it's exciting time to be in telco and connectivity, I would say.
Yeah, thank you very much, Clemens. And 1 gigabit, that's very impressive, really. Having said that, and thank you for mentioning the launches with the European launch providers as well. Now I'd like to go to Juan Ramon, because we touched on 2 different innovative technologies. And now maybe it's time to look how European Union in general will take advantage of these new challenges and benefits.
Thank you. Good afternoon to everyone. I'm pleased to be here today. Let me start by saying that the European Union Space Program already identified the development of strategic capacities for the member states, and the European Union Space Program Agency is already developing and launching very soon some of the initial capabilities. So this is based on a breakthrough innovation, what we call the GovSatcom Hub, which is going to offer secure satellite communications to the member states, thanks to a pool of capacities based in an initial stage with the governmental member states' capacities. We are launching this before the end of the year. So member states would be able to get access to different raw capacity end-to-end services, including terminals and so on, for running their critical missions, whether they could be, critical infrastructure protection, surveillance, or when disasters happen for disaster relief applications. So this is going to be a very strong value proposition composed of 5 governmental resource providers existing in Europe with their existing capacities, including new generation satellites. We start with GEO satellites. They are mainly military satellites with the latest technologies, protection waveforms, as well as technologies on board to protect from interference and this kind of value propositions. And the added value here is that this GovSatcom Hub that is co-created by USPA in collaboration with industry is pulling all these capacities and sharing them between the member states in a question of a few clicks. So they will get access to this marketplace, to this one-stop shop for the member states to be able to run their missions. Complementing this, let me give you a little bit of roadmap of these capabilities and how we are growing a long time. Before the end of the year, we are launching what we call this GovSatcom Hub initial services. But after that, we are building as well the full operational capabilities. So we'll be growing the catalog of providers, including commercial providers, a long time in the coming year. And at the summit, if you want, getting close to the end of the decade, we will incorporate in this portfolio, obviously, the IRIS² capability, a multi-layer constellation composed of MEO satellites and LEO satellites, around 300 satellites that would also be able to offer very low latency services to all member states of the Union for the critical missions worldwide. So I think we are building very strong capabilities to increase the resilience and the security of the Union thanks to these relevant programs. And we're working with all the European Union member states to ensure the missions can be run smoothly worldwide.
Thank you very much, Juan Ramon. So now we are going to go back to a little bit more spectrum management and direct-to-device angle. And I'd like to give the floor to Richard from Ofcom.
Thank you. So Richard Moore from Ofcom, the UK telecoms regulator. So I thought I'd use these few minutes just to explain why we're interested in direct-to-device and what we're doing to enable it in the UK. So as a regulator, obviously our primary mission is to improve connectivity for businesses and people in the UK, and direct-to-device offers that opportunity. And in my group within Ofcom, in spectrum management, we're always looking for ways to extract more value from the spectrum and make more efficient use of it. And again, direct-to-device, particularly the flavour of direct-to-device which uses existing mobile spectrum, offers that opportunity. The UK actually has pretty good 4G coverage, so we're edging towards 95% geographic coverage. But there are parts of the UK where you still can't get a reliable mobile signal, particularly in deep rural areas. But in addition to extending the coverage of existing networks, we think it's important to have a resilient backup to the terrestrial networks, particularly as we see more climate-related outages on the networks. And on top of that, particularly for C&I, so if you think about electricity networks and other critical national infrastructure, having that alternative to terrestrial networks in times of disaster could be particularly important. I think beyond that sort of improved connectivity, there's just a huge amount of innovation and investment going into this sector at the moment. So we want to be at the forefront of that. So enabling those sort of services in the UK is important to us. We don't think it's a panacea. We don't think direct-to-device is going to provide massive connectivity in terms of capacity. It will probably be basic messaging and data services to start with, potentially voice later on. So it's not going to replace our mobile networks, but it does provide that resilience and backup. Briefly, what we've been doing, so we've been looking at this subject for the last couple of years. We ran a sort of call for input last year to assess the demand for offering these services and the demand from consumers and other groups. We looked at both direct-to-device and existing mobile spectrum, in the traditional mobile satellite spectrum, and also we looked at high-altitude platforms as well as an alternative to satellite-based direct-to-device. Earlier this year, we ran a consultation, zooming in, honing in on the direct-to-device and mobile bands. We made some proposals as to how we would authorise those services in the UK, primarily around how we would require a partnership between a mobile operator and a satellite operator to provide that service and coordinate the spectrum use in the existing mobile bands, but also technical conditions to make sure there isn't any interference. So when you use these satellite transmissions, that existing spectrum users, both in the UK and overseas, are not impacted by those services. And so that was important to establish those rules to make sure existing spectrum users are protected. We closed that consultation. We put out a statement last month nailing down some of those technical conditions. We're just finalising some additional consultation points, and we hope to have our framework for direct-to-device and mobile bands in place by December of this year. And therefore, it's really up to the mobile operators partnering with satellite operators to introduce the services from next year. So we're very excited about that. We in the UK, we're moving ahead of the WRC, the ITU process. There will be an agenda item in 2027 at the WRC where a lot of these things will be harmonised internationally, and we're committed to reviewing the way we do things post-WRC to make sure we're aligned with in the international agreements as to how these services work. And finally, just as we might touch on it later, we're starting work now looking at the 2 gigahertz mobile satellite spectrum and how that might be used post-May 2027 when spectrum in that band becomes available after the expiration of licenses currently held by EchoStar and Inmarsat. So, thank you.
Thank you very much, Richard. So I'd like to give the floor for the introductory remarks finally to CEO of Satelliot, Jaume.
Thanks. Satelliot is a company born 2018 in Barcelona. We have the European 5G satellite constellation that will deliver wideband services globally. Why? 90% of the world does not have coverage of the mobile operators, and satellite solutions today are too expensive for the vast majority of the use cases. What we see is that, apart from that, Europe needs sovereignty on the satellite communications, and there is a huge need of 5G connectivity outside the reach of the mobile. Which is the solution? The solution is to have satellites that have the capability of connecting directly from the space 5G devices, IoT, and new radio in a global way. Which is our traction? We already launched 6 satellites in the past. This September, last September, we connect for first time in history 5G IoT chipset, NB-IoT chipset from Nordic, directly from space. This is an historic milestone that has happened here in Europe. We have already signed with more than 400 companies binding orders in order to deploy thousands or millions of devices worldwide. We have a strategic backing from Indra, Cellnex, the Spanish government, of course. We have some projects with the European Space Agency, more than 10 patents, tens of contributions to the 3GPP standard. We were the #1 contributor to the release 17 of the standard from space, and a lot of hours. We have a roadmap. We already launched these small CubeSat satellites. Now we are preparing the generation 2 satellites, 150 kilo satellites, which 5G IoT and 5G new radio capabilities. The idea is to launch a global, real-time, low-latency constellation before 2030 to deliver defense use cases, ISR in real time, autonomous systems, secure tactical communications, smart logistics, predictive maintenance, and cyber security and resilience use cases, disaster response, environment monitoring, critical infrastructure, because we believe that Europe needs a sovereign standard-based space layer. Thank you.
Thank you very much, Jaume. So, satellite communications was traditionally very expensive, used dedicated devices like a bulky satellite phones or very big dish antennas. Now we are moving to a new ecosystem. There are new market entrants. There are new methods of using the spectrum more efficiently. And there are new questions about starting from the spectrum management angle all the way to the socioeconomic decisions that countries, or in Europe's case, regions, will have to make. So we have 2 satellite operators, one technology company, one regulator, one EU agency here. I want to check first if there is any question in the room. If not, I'm going to start by asking Clemens about Project Kuiper. So Europe is fairly well connected in residential areas, and I'm guessing in rural areas it would be better than the rest of the world. I don't have the numbers with me right now. How a satellite broadband operator like Project Kuiper will be integrated into the rest of the European connectivity landscape? And will there be any partnerships with the rest of the European industry coming on? Mm-hmm.
So yeah, the numbers differ actually quite massively. And me coming from Germany, we're not the front runner when it comes to FTTH, for instance. So there are even in Europe larger white spots, or at least underserved areas. So there is the need for an improved connectivity situation. When it comes to your question regarding how does that fit into the European connectivity package, we are a strong advocate in actually rethinking this approach and actually integrating all existing technologies in order to achieve our connectivity goals in Europe. Research shows that there would also be a lot of potential subsidy savings attached to that if we would say, okay, for the last 1%, 2%, 3% coverage, that is usually from a rollout perspective the most expensive part of the rollout. If in these areas we would rely on, for instance, LEO-based solutions, we could save massive subsidies, and we could achieve these connectivity targets faster. So we would say there is, regarding the digital decade goals and everything connected to that, a lot of potential in actually integrating satellite connectivity into that mix. Although it is clear that, although I mentioned 1 gigabit, satellite connectivity is not a replacement for terrestrial fiber connectivity. It is a different form of technology, but it is a complement. And this complement can be seen as a complement in achieving political goals, but it can also be seen in a complement for an end customer who maybe just wants to access really fast internet and does not want to wait for a potential future fiber connectivity.
Thank you. Thanks for highlighting this complementary angle. I think this is sometimes misunderstood, even in our industry, that satellite operators will come and take lunch from the rest of the industry. I want to go to our other satellite operator, Jaume, with the same question. So with Sateliot, how you are gonna integrate yourselves into the European connectivity landscape, and what type of partnerships or industry collaborations you are planning?
To integrate with the existing telecommunications industry, the first is to talk the same language. This means the satellite constellation that we are deploying works with exactly the same devices that today the telecom operators use. No new antenna, no new radio chain, no different frequencies, just a firmware update. The release 17 is the minimum for IoT, okay? 5G new radios exactly the same. And second, it's the interface with the mobile operators. We are a GSMA partner. Then our satellite constellation is connected to a 5G core. This means that we do fully standard roaming agreement with them. Apart from that, of course, it's important to integrate with across the industry with chipset manufacturers, where we are working with companies to have those certified with the industries in order to find the best use cases to use the full power of our solution. Mm-hmm. This altogether is what it makes that our infrastructure is fully integrated with the existing ecosystem.
Mm-hmm. Thank you. And when we think about integration between the terrestrial networks and non-terrestrial networks, I mean, this is one of the most discussed topics. I want to ask Uwe his opinion. When we discuss this integration between different networks, do you think regulators' roles and responsibilities are changing, and how they can continue to enforce the efficient use of spectrum, no interference, etc.?
I think Ofcom mentioned this is at the moment being harmonized on a worldwide basis in ITU. So we will have, I think, a long discussion in 2 years at the World Radio Conference in 27. Actually, the discussions are ongoing, so the preparatory study groups for this event are meeting right now in Geneva, and I think they have a lot of fun discussing the impact of the spectrum harmonization right now. Of course, you have the classical spectrum for mobile satellite service. I think that's one piece, and then you have the piece which is the so-called IMT spectrum. That's the ITU terminology for all the generations that we have in our mobile phones. So where we now get direct-to-device, and the clever thing of direct-to-device is that you operate on the frequencies that are already implemented in your smartphones. That is doing the trick, right? Because overnight you get a super large customer base because everybody has these devices already. So in most of the models that we see, for example, where we have regulation, I think Ofcom is quite advanced in this, but also in the US, we had the supplementary coverage from space. There's always the combination of a terrestrial network operator with a satellite operator or a satellite connectivity provider. So that is something where you basically have the same regulation. Also, I mean, we have to talk about lawful interception, for example. So that needs to be guaranteed if you offer a communication service. And these kind of things. And this comes automatically when you do this combination with the terrestrial operator, with the satellite operator, because you basically go into the core of this terrestrial network operator. In the future, we may have, of course, more interesting discussions if we would have satellite operator which would be standalone, and then we really need to think about how to do the regulation and do the data need to come into basically on Earth on a teleport which is in Europe. These kind of things may need to be considered. From a spectrum management point of view, I think that is pretty classical, who gets the allocation. Of course, for satellite, the very specific thing is that more or less it makes only sense to have a European harmonization. I mean, still, I think the spot sizes for direct to cell are around 30 kilometers, maybe a little bit larger, 50, 30 kilometers. So it necessarily means that you always have cross-border harmonization need for that. But that maybe is another question, which of course you need maybe equipment that my company is doing to guarantee that. So we are quite optimistic about that you can achieve that in the future. But again, also you need to see what you really can achieve with direct-to-device. It's not a broadband service. It's the service that we mentioned, that you have an emergency call or you have a texting or something like this. That needs to be clear. And I think even those need to be proven on which scale this will work. Is it 10 mobiles in one beam? Is it 100 or 1,000? That is still something which need to be proven and tested.
Thank you, Uwe. So harmonization is always important, of course, but in the context of Europe, for satellite connectivity, yes, it is one of the most important things. So having said that, actually in Europe, there is a harmonized frequency band, which we call generally 2 gigahertz, 2 gigahertz MSS band. And I believe in 2027, there will be a reallocation by the European Commission for the European Union countries. And I believe that Ofcom, Richard, you already mentioned the consultation, that you are carrying out the consultation. So currently, this band is allocated to 2 satellite operators. But now we see that new entrants are also interested in this band and the others. So, Richard, my question to you will not be directly about 2 gigahertz, but about this. For satellite, we have a limited number of available frequency bands, and there is more demand than the supply. How regulators can respond to this challenge about the demand side?
Yes, it's a good question. So, as you say, in the 2 gigahertz band, it's basically 2 times 30 megahertz of spectrum, currently shared between those 2 operators, Viasat, Inmarsat, and EchoStar. We ran a call for input, again, to understand what the demand, what sort of applications, what sort of benefits could be delivered. We're sort of doing that in parallel with the EU process. We had, I think, over 21 responses. As you say, a mixture of the incumbent users of that spectrum and new users, and a mixture between direct-to-device type services, quite a lot of IoT type applications, so a mixture of narrowband and, I wouldn't say broadband, but sort of 3GPP based services. And clearly, there is a risk that there is, or not a risk, that there is more demand than there is spectrum available, and so there needs to be some sort of allocation process. The nature of MSS spectrum, unlike sort of fixed satellite service where sharing is quite common co-channel, in MSS traditionally you have chopped the spectrum up and allocated bands to each operator. Obviously the more you put in, the less each has, so the economics of their business reduces, and potentially have GAR bands, so the efficiency of the spectrum use reduces, so you have to consider the optimal number for competition and innovation against the use of the spectrum. In the IoT space, some of the traditional technology, or some of the technologies like LoRaWAN allow people to share co-channel, so you get more of a sort of listen before talk, or at least random access channels. So it will be interesting to see how things play out, whether the spectrum is allocated to sort of 3GPP standards, or there will be a mixed economy in there. I think in Australia, for example, they have allocated some of that spectrum for a more sort of almost, I think they call it a spectrum park, where there's a bit more innovation, smaller players can come in and share spectrum. But clearly, the process over the next year or so is going to identify that demand and work out the best allocation mechanism. It's the perennial problem for a regulator to balance the supply side of the spectrum with the demand to optimize the outcomes for end users, and do that on a pan-European basis. Obviously, it adds a new dimension of complexity to it as well.
Thank you. So now I'd like to turn to Juan Ramon. So you mentioned what you have been doing on the secure communication side, and you mentioned IRIS². So I understand that there is a separate list of requirements for the secure communications, of course, but at the same time there is a need for global cooperation or regional cooperation in Europe outside with the non-EU countries. So how you are planning to balance the secure communications needs with the need for global cooperation?
Thank you for this very important question. So let me start with the European Union Space Program regulation. There is clearly recognized the need of secure communications for the European Union member states as, I would say, a pillar, an essential pillar, while at the same time looking for the autonomy of the Union, in particular regarding key technologies like those that would be used for IRIS², and preserving as well an open economy. So how this balance can be achieved, in particular when security is at stake here for some of the critical applications. The way we do this is, of course, in cooperation with all the European Union member states, by defining the eligibility criteria according to the different criticality of their missions. It's important to understand when there's a crisis situation, member states need to get access to secure communications, assured communications, and they need to understand they should be there when they need it. So this is one critical requirement we consider. This is in particular very relevant for this start phase that I mentioned before, by addressing through the GovSatcom Hub initial services, these initial capacities from the member states, from the existing 5 providers. And a long time, I refer to the possibility to also launch the commercial capacities that could join part of the portfolio. This is, of course, in relation to security and eligibility criteria that would be defined according to the different needs and applications from member states. So this is an important area of cooperation with additional providers to offer these capabilities worldwide. And in the case of IRIS², we are already working with leading global satellite operators as part of the SpaceRISE consortium. So they are already delivering this kind of services today worldwide. And we will have plenty of partnership as part of this consortium. So most of the European industry players would be part of this endeavor. We have a very strong contribution from SMEs expected as well across Europe. And I mean, plenty of member states and their industry could be able to join in this development of IRIS². This is one of the areas of cooperation. We should not forget as well that IRIS² would offer commercial services also addressed to the digital divide. So this, because it's a public-private partnership, so it's a very strong cooperation. It's the first time that in Europe, in the space sector, we are launching this PPP, cooperation with the industry. And the operator would be able to offer these commercial services as well worldwide. Now let me focus also on the possibility to benefit if you are like a third country, I mean, as an external partner of the European Union, it's still possible to join as a third party these kind of initiatives. So the regulation already foresees these potential cooperation, so through bilateral agreements with the unions, and non-EU member states could get access to this rich portfolio of capacities, including IRIS². This is a possibility that is envisaged. So here we have different kind of cooperations possible to enrich the portfolio for the benefit of everyone.
Thank you, because the coverage will be global eventually in the IRIS².
Sorry?
The coverage will be global.
Yes, it's global, the coverage. So it's we are dealing with two frequency bands, MIR-K, K, and KU, basically, and with global coverage, MEO orbit and LEO orbit, and low LEO as well. So it's going to be a multi-layer, multi-orbital constellation with around 300 satellites.
Thank you. I want to prioritize if there is any question in the room, because you woke up this morning, get prepared, and came here. If not,
we do have a sent-in question. Maybe
yes,
people are shy and they're typing in their questions. The number one question with the most votes here is, sending up satellites is nice, but have you thought about the waste when the satellites become obsolete or unusable? What are your plans for solving that?
So I think I'm going to give the floor first to Kuiper. Is one of the
it's probably it's a very important question, because as I mentioned in the beginning, like maintaining an ecosystem in space that is safe to use, that's sustainable to use, requires thinking about this from the beginning, and that's what we did when we designed that constellation. So I want to pick out two or three things regarding the satellite design itself. We operate in very low orbits, so 590, 610 and 630 kilometers, and all of our satellites are actually maneuverable, have enough propellant to maneuver, not just to avoid some kind of collisions, but actually to deorbit. And the lifespan of those satellites is factored into that. So we can make sure and guarantee that all of our satellites that we shoot up will actually deorbit without leaving any remains and any debris in the orbits that we use. And this is not something that we only do because we think it's important, but also the whole thing about space safety is also in all operators' self-interest, because although launches and operating space systems is getting, well, cheaper, let's put it in easy terms, it is still a massive investment. And having like systems in orbit that might basically just collide and vaporize is nothing that any operator would like to see. So space safety and sustainable space use of space is number one priority for Kuiper and has been from the design phase on.
Yeah, thank you. Yeah, sending satellites is definitely not easy. Is there anyone else who would like to react to this question? If not, maybe we can get one more question and get a very quick response. Is there any other question?
Yes, we can. Actually, a new question just popped in. How to ensure that 2 gigahertz MSS allocation done in 2027 will benefit and introduce service to whole Europe, including Nordic and the Arctic areas?
Yes, I think it's also about the coverage areas. So, Jaume, is this something that you might react in the next 30 seconds? As the satellite operator.
I will do my best. Okay. Yes, of course. When you launch our satellites, they are polar orbits. This means, okay, that we have global coverage everywhere in the world, including the Arctic. Then it will depend the service on the frequencies, okay, but we have already allocated frequencies in more than 30 countries, and we are working with 100 altogether, including Europe, of course, where we are pushing, that this S-band that today it's assigned to US companies, it becomes European again.
Thank you. If this question belongs to a European citizen, actually, they can also address their wishes with the European Commission, which will be the decision maker on this band in the European Union. But for the rest of the world, I mean, I think everyone is watching what's going to happen to this valuable band with excitement. So having said this, do we have another 5 minutes? Okay, wonderful. So I'd like to, yes, Clemens, is there anything?
Yeah, just one thing, because you before talked about integrating systems into existing terrestrial networks, and this is one thing that I wanted to point out. Besides all of the discussions around direct-to-device, we have started discussing with mobile network operators about backhaul access solutions. So basically integrating satellite connectivity into the cell towers that might be hard to connect via fiber in order to improve the capabilities of the terrestrial mobile networks. And that's just one example where this integration and cooperation aspect also comes into play and has direct effects.
Yes, I understand. So I want to ask to the private sector. If you, there is one regulator here, but I know that there are other regulators in the audience. If you had one call, one wish to the regulators, I mean, about the challenges that you face, when you are trying to innovate, when you are trying to operate, what would be that one wish, one call? Maybe, Jaume, I can start with you.
Globally?
Globally or in Europe?
In Europe, to harmonize the spectrum and market access.
Market access. Do you think there are challenges in market access in Europe?
The S-band is the first one, okay, that has been harmonized in the whole Europe, but there are all bands coming that we expect, okay, that this follows the same trend.
Okay, understood. Uwe?
Yeah, if I could have a wish, then for regulator, then of course every regulation stands and falls if you can enforce it. And so I think regulation needs to be written in a form that you can really enforce it, or you must have the right tools to do this enforcement. So that would be my wish for a regulator.
Okay. Clemens?
Yeah, as a global operator, I would say more on the, not on the regulatory, but more on the legislative side. Like the target should be in something that is like global per se as space, to have uniform rules, and regulation should be based on, ideally, on international accepted standards and not deviate massively, because space assets are there for a longer time and are designed with a long time ahead, and having regional differences in the regulatory parts is quite challenging. So uniform rules would be great.
Thank you. Juan Ramon, Richard, if you have any wishes from the national regulators, I mean, please jump in. Otherwise, I'm not going to address you with this question. So I think we reached to the end of our panel. We touched on a lot of different things, starting from the spectrum harmonization, which is mostly a technical question, but then it goes to the economic angle and even the political angle. And we also went all the way to the coverage, etc., the socioeconomic benefits, and then to the space sustainability, which will be dealt, I believe, in Europe with the EU Space Act as well, which we haven't touched on this one. Having said that, I'm going to thank all of you, and I'm going to pass the floor to Artis.
Gökhan, excellent job, excellent panel. A round of applause to our experts.